the idea about this mini-conference is about that the artificial intelligence is around us, it's over us, up. And it is now a very strong topic, how to use also this AI in architecture. The mini-conference or the seminar about this topic is not my idea, but I know about this issue ERA 21 from the last year and small conference in Brno about this topic. Not about the topic architecture versus AI, but about the topic AI-tektura. About this, how to use, how is the dialogue about the AI in the Czech Republic, in the platform and focus of the architecture. I would like to invite here the chief of the ERA 21, the absolvent of the Faculty of Art and Architecture, Technical University, Liberec, London. And a very important person from the High School of Applied Arts in the Prague, Shota Chikolia. This is a very expert about the parametric architecture, AI, combination with the classic architecture and other. And also Jiří Vítek from this faculty, this is also the absolvent, and this is a very important person now. And the last presenter will be my son about the render and AI, but I don't know where my son now is. Okay. And the first, thank you very much for your coming, and thank you very much for the support of the faculty. And now I would like to ask for some few words.
I will a little bit introduce the ERA 21 magazine. I hope that the Czech students know this magazine. Is that true? Yeah. I also brought with me 20 pieces, 20 hard copies of the magazine, so you can then take it if you want. I think we have just 20, but we are 20 students here, so maybe everybody can take one piece. And ERA 21 is the magazine that focused in every issue on a different topic. So we have very wide field of goals, of issues. We can focus on architecture in urban context, on architecture in small context, and also, for example, in architecture in a relationship between architecture and AI. So that was the issue which we focused on October last year, and as editor, I'm not able to know everything about every topic, so that's the thing that we always invite some external curator or editor for some external editor that can help us with this issue. So I invited Shota to this issue about AI, and we tried to focus very deeply on this topic, and we have very important persons in it. For example, Mario Karpo or Neil Leach, who is also expert in this field. Matias Del Campo, Daniel Bolojan, Benjamin Bradňanský from Slovakia, who leads the atelier in University of Applied Arts in Bratislava, or also Jiří Vítek, who is here. So that's just for introduction of our magazine, and I'm also happy that I can come back on my alma mater, on my school which I studied. When I studied, this building G didn't exist yet. It was just under construction when I finished my studies. And I am happy also that I see my professor Jiří Suchomel here. And now I will pass the words to Shota Cikolia, and he will tell you more about this topic of AI-tektura, how we call it in our issue.
Okay, thank you, Philip, and thanks a lot for letting me participate in this Era 21 edition, which I think it was a very exciting experience for me. Hopefully it would be also exciting reading, or was exciting reading for those who read it. I don't think I can call myself in any way expert on AI. Maybe part of my expertise is digital architecture, and in that relation I'm interested in AI maybe a little bit, but within this magazine, within this Era edition, rather than trying to provide expertise, I tried to be a sort of a guide and find experts in the field. Hopefully it was, it ended up with some interesting readings and articles. I will just very briefly introduce myself. I combine two places where I work. It's architectural studio Colarc, which we co-founded with my colleagues, and I also teach at Umprum, at the Academy of Arts, Architecture and Design in Prague, together with Imrem Vaškem, my former professor, now a colleague. We are teaching Studio Architecture III. In both of these places, my sort of field of interest is to look into how digital technologies change architecture, and perhaps specifically in how this change can help architecture to be more relevant in time of crisis, environmental crisis, but maybe also social crises. Of course, academic field at Umprum allows much more freedom than the commercial practice, where we are limited obviously by constraints of budget and so on. But in both of these practices, we try to look into these topics. Jumping into AI. So as Dan mentioned, it's everywhere around us. The proof that it's everywhere around us could be also that I was coming to Liberec from Prague today. I turned on the radio and I was listening to Vinohradská 12. Maybe some of you probably know this podcast. And just yesterday and today there were two kind of very futuristic topics. One was about this cloning of direwolves, which you probably heard. Another one was about a prediction made by a group of scientists from San Francisco, from Bay Area, which expect huge qualitative changes in the development of AI in very recent future. They did a prediction, short-term prediction for maybe 6 months. Based on that, another short-term prediction, another one. Of course, this means it's like a weather forecast. The forecast for tomorrow maybe is pretty precise. The forecast for 1 month doesn't make much sense. Still, they predict not quantitative but qualitative changes, and even if those changes would not happen or would not happen in the timeline they mentioned, everybody is talking about it, and just by discussing it, AI comes to our lives. So when I was asked to help with the Era 21 edition, I was thinking that I'm not going to write an article about any particular topic of field of AI influencing architecture. There are better specialists in that. But I would like to make sort of an introduction. So when later Neil Leach is talking about GANs, or when somebody is talking about large language models, or when somebody is talking about backpropagation, these words are understandable by the readers. So I started with some sort of a alphabet of AI, abeceda AI. When preparing this presentation today, I thought that's how I'm gonna build it. I would just illustrate each letter, or maybe I would not go through every letter, with some project which I find interesting, very rarely maybe even my project, or maybe just my thoughts about the topic. So don't take it as some kind of objective presentation about AI. I'm not a right person for that. Take it as kind of my personal experience with this development which happened in the last couple of years. Okay, A as AI. Obviously, starting with AI, we are immediately dealing with two opposites. Maybe you heard term narrow AI and general AI. General AI often is called AGI, or artificial general intelligence. And I would like to say we're somewhere in between, but no, we're not in between. We're very solidly within the narrow AI. To understand the difference, basically you can think about it in this way. When you have a tool which is not a straightforward tool, it's not some sort of mathematical formula which you can clearly see and understand, but maybe a bit complicated tool like a black box, which is very good at dealing with one particular task. That's narrow AI. When you have this black box so powerful that it can itself decide what task to deal with and how to deal with it, and maybe learn more and more, and have some sort of agency, that's general AI. I like to illustrate it with these two images. The image on top, I guess most of you know Metropolis, where this dream of intelligent robots was visualized in a very beautiful expressionist language of German cinema. However, the idea of machine which can think and which can act on its own maybe is even older than that, and definitely older than all of our attempts to build actually a functioning AI. And we're nowhere near that at the moment. Great example of narrow AI is AlphaGo, which you can see down here. It was a software developed with one specific task: to be great at the game of Go, which is, I don't know if any of you play Go, but or heard of it, but basically the game of Go is interesting that it has some similarity with chess, but while it has simpler rules than chess, you just have black and white types of objects. It has much more variance where to play, because there are more figures, the play is bigger, and so on. For that reason, game of Go for a very long time was extremely complicated to deal with computers. So my personal experience, I think in the year 2008, I was going to, in Umprum, I was visiting a class called Game Theory, and our teacher, who himself was amateur Go player, he was telling us that at the time, the best computer made to play Go is much weaker than he himself, an amateur player. So there was huge difference between the Go professionals and any computer. And that is 2008, so it's 10 years after Deep Blue computer defeated Garry Kasparov chess champion. So it's not that long ago, and computers were already very powerful. These computers didn't use anything similar to nowadays understanding of artificial intelligence. They didn't use neural networks. They used sort of more linear branching algorithms. To put it simple, they worked in a way, okay, analyze the situation, try out the most promising steps, do these steps, see the most promising continuation, and so on and so on. And if you work this way, the amount of possibilities grows exponentially. So game of Go was much worse than game of chess because there are so many possibilities. AlphaGo, I think it was 2017, I might be wrong, but I think 2017 was using different logic. It was using logic of neural networks. Again, if I put it in extremely simplified way, that would be, it played at first against other players, then against itself, and rather than calculating what the move would lead to, it just tried to memorize patterns. Okay, this pattern where a bunch of figures is here led to me winning, these patterns led to me losing, and so on and so on. So it used completely different logic, and with that logic it was able to train itself, I don't remember the time, but maybe in a couple of days, in very short time, to be so good that it defeated the world champion in Go, and since that they weren't even testing computers versus people, because that was completely one-sided. This is a great example of narrow AI, which is doing extremely well one particular thing. But you can also see that there is great difference between the science fiction idea of machines taking over the world and this sort of thing. Staying a bit within science fiction, Turing test. When we speak about AI, often a question is raised: what is intelligence? I already mentioned that computers were defeating people in chess since '98, but nobody really called Deep Blue artificial intelligence. It works in a completely different way. It's basically, it works as a very sophisticated calculator. But then again, the machines which we have now, which are running stuff like ChatGPT, also are based on semiconductors and electricity. So what's the difference? The answer, or proposed answer to that question, was given by Alan Turing, great British mathematician, famous for inventing first computer-type machines, let's put it that, or also helping in breaking Enigma code during the World War II. And he proposed that if we need to say whether a machine is intelligent or not, we don't really need to know what's inside that machine, as we don't really know what's inside our brain, at least not completely. We just need to know how it behaves. So Turing's test, again, sorry for those who already know it, is very simple. Imagine that you are speaking with two persons. You as a human are speaking with two partners. You ask them the questions and they answer. You don't see them because they are, for example, behind the wall, and you don't really hear them. Maybe they give you the answer on a piece of paper. If by the answers you can, and one of these partners is a real person, another one is a computer. If by these answers you can tell which is which, then it's still not intelligent. It hasn't passed the Turing test. As long as computer is able to answer your questions so realistically that you wouldn't know which is which, no matter how long you ask, how many questions you ask, how experienced you are, then you achieved this artificial intelligence, according to Alan Turing. That was, for a long time, very famous kind of approach, and for a long time completely unreachable. Now it's a big question. I would say myself almost certainly that contemporary large language models, chatbots like ChatGPT, DeepSeek, etc., would pass the Turing test easily. But even before that happened, there were also questions whether this test is good enough. One of the counter-arguments was so-called counter-argument of a Chinese room. Imagine that this box where the computer should be, or a person should be, as a room where there is a person who gets all these questions in Chinese. The person himself, he doesn't speak Chinese, he doesn't understand what the questions are, he just around himself has a huge catalog, infinite catalog of instructions, like if you hear this word, you answer with that word. If you hear this, you answer with that. Theoretically, with this sort of catalog of instructions being infinitely big, he would pass the Turing test while not really having any understanding of Chinese. So you can't say that this person, in this sense, is intelligent. So the question is this what's happening in case of large language models? Is it just that the amount of instructions is so big that without any understanding, you can say that the computer passes the test? My personal answer would be probably yes, but maybe it's not. Maybe it's not a problem. One of the interpretations of this Chinese room was also that maybe the person inside the room doesn't speak Chinese, but if you think not about that person, but about a system, including that person plus the instructions, together they could be understood as an intelligent being. So maybe that's one way of thinking about this. It's interesting that this idea of testing not through looking inside, but through comparing differences with an actual person, got into mainstream culture with the movie Blade Runner, where again the machines were compared with humans by their reaction, by their ability of empathy. And already in Blade Runner there were questions about the meaningless of this test, whether it makes any sense or not. Okay, so I already mentioned a couple of those things. So I have here L as large language models, LLMs, and C as chatbots. These two are connected, obviously. Contemporary chatbots are based on large language models, and these two things are probably, or large language models are probably at the very forefront of the artificial intelligence research. Most of the people would know ChatGPT, China developed DeepSeek, large language model. There are a couple of others. In Europe, there are big talks, big discussions about developing European language model. So I would say that this is where the most money and most effort goes right now. This is also thing where we can see the result of implementation in the field of architecture the soonest. It's maybe less attractive as diffusion models, like the things which generate images, like Midjourney or DALL-E. But there was a research according to which, or survey, not research, a survey according to which in England already now about 40% of construction specialists, people who work in construction, architects and engineers, use to some extent large language models in their daily routine or in their work. I'm not sure about daily routine. You can imagine this in the simplest possible way as sort of artificial secretary. You need to write an email, large language model will write it for you. You can imagine it in more complicated way. There is a Chinese company called ITKE, which uses not only large language models, to be fair, it uses also other tools, but it's built around large language models to automatize lots of tasks of an architect. And I'm not now talking about so much about coming up with futuristic concepts, about ideation, but more routine, mundane tasks, again, something which you would expect to partly maybe outsource to secretary. And it starts maybe from preparing, from helping with drafting, but it ends with things like writing text descriptions of your projects, preparing all the documentation, and so on and so on. Anybody who practices architecture would probably confirm that this, maybe unfortunately, is a very big part of the work. So while AI in architecture probably came to the life of most of us with very beautiful images generated with diffusion models, right now I would say that majority of its application are large language models. And whether to the worst or to the best, I can't judge for now. Okay, now maybe a little bit to the mechanics of AI. What is it? I really waited for a long time to put this comics in some presentation. Finally, I found an opportunity. But I think it's actually not such a bad explanation of how neural networks work. You put a lot of data inside. The more data you put, generally the more resilient is your network. And then, whether through supervised learning or through unsupervised learning or through reinforcement learning, you basically teach your network to distinguish good results from bad results. With supervised learning, it's quite straightforward. You basically say, okay, if the input is this, the output should be that, and you say it many, many times. With reinforcement learning, you support or you somehow not improve, but yes, I can say support the good results and try to negate the bad results. With unsupervised learning, the network does it itself and feeds the results back. So part of it is also the evaluation mechanism. So it kind of teaches itself. It first runs all sorts of results, then kind of evaluates and compares results with the input. In fact, what we have now is a combination of all three. You need sometimes supervised learning, especially at the beginning. You need reinforcement learning through most of the process. At some point, the amount of data is so big that the learning could be unsupervised. In any way, the idea is you feed a lot of data and you wait until the results start to be meaningful, start to be relevant. That is also kind of current main distinction of this sort of machines, of this sort of tools, from stuff like Deep Blue computer, the chess computer who defeated Kasparov in '98. Basically, with Deep Blue, we knew exactly what was going on in the middle. Here, we get the complexity so high that we have no idea what's going on in the middle. We see the input, we see the output, we can say whether output is good or bad, but we don't really see the inside. For that reason, neural networks are often compared to black boxes. When I think it was around 2016 when supervised learning, unsupervised learning, reinforcement learning, these topics came to my attention and generally came to more mainstream attention. I also cooperated with my colleague Julia Brunner from UCL London on a workshop which was part of his PhD thesis, which tried to include this sort of ideas of, in that case it was supervised learning in architecture, in particular in fabrication. The idea of his was that, of course, 2010s, from 2008 to 2020, was a time where all academia, all schools were super crazy about digital fabrication, particularly robotic fabrications. Whoever had money were buying robots, whoever didn't bought at least 3D printers and did all that stuff. The thing is, with first generation of robotic fabrication or digital fabrication was that these machines were really good with relatively simple, straightforward processes, like CNC mill. You just show the path and it cuts stuff off. Or like 3D printer, you show again the path and it extrudes material. As long as the material behaved behavior was very predictable, like with plastic, it worked very well. When it was a bit more unpredictable, like for example concrete, it was a little bit more difficult, and we're only now starting to get to know how to work with it. But whenever there was more complexity in the fabrication process, something which craftsmen, which artisans do, the machines were quite limited. And the idea of Giulio and his colleagues was to apply our knowledge of AI, of supervised learning, to make machines be able to maybe not substitute, but at least cooperate with craftsmen. His idea was very simple craftsmanship, chiseling wood. Unlike CNC milling wood, where you go uniformly through the material, to do chiseling, you need to know wood, you need to see where the internal fibers are, you need to have some feeling in your hands when you chisel. And that's something which machine is not very good at. Until what they did was they would put a force sensor within the chisel, they would calculate this chiseling process done by craftsmen, and then they would put the same sensor within the robot, and then they would do this exact supervised learning process. They would train neural network, which would know that out of this pressure and this movement comes this result. Out of that pressure and that movement comes that result. And it would create its own black box, its own pile of data, which would make connections between the two, and then it would be able to learn it. I like to show this example because while it's maybe not super super attractive from visual point of view, it's something very different from what we think about when we talk about AI in design or in architecture. A very similar project was done at the same time in Copenhagen at Academy of Arts, where instead of chiseling, they were deforming thin sheets of metal in order to, through the deformation, get structural properties they needed. So in this case, the result was very thin-shelled, very thin shell structure, basically a bridge. And this bridge is solid because these are not flat sheets, but because they are deformed. Again, this deformation is not straightforward process because when you deform a sheet of paper of metal, it gets thinner. So we need certain feedback, and that feedback was achieved through this supervised learning and training of a neural network. That brings me to a little bit of a maybe theoretical thought. Mario Carpo was already mentioned today, and he has a really interesting interview, and I think also an article in this area edition. And he has this kind of thesis of his about the place of digital technologies in general, but maybe AI in particular, in the development of architecture. It's related to two things. One, he likes to distinguish autographic from allographic architecture. By autographic architecture, he talks about architecture which in Europe we associate mostly with pre-Renaissance era, the time where architects and building craftsmen were often the same person, and he calls it autographic because you can almost literally feel the hand of an architect on the shape of a building. Architect was on site, and the connection between what's the idea in his mind and the building was direct. Allographic architecture he traces from Renaissance, from Alberti and further on, and through industrialization and to nowadays. And for him, allographic architecture is an architecture where architect puts his idea on the paper, on the drawing board, perhaps also in the computer, in AutoCAD, and then somebody else builds it from the drawings. So what architect designs directly is not the building, but building's representation in the drawings. And he feels that this barrier is as significant for architecture as, for example, book printing is significant for the spreading of knowledge. He believes that nowadays change of technology, where architects not only create drawings which are then realized by other professionals, but sometimes directly create scripts which put robots and other digital machines in motion, and through AI that process becomes more achievable for everybody, is a sort of a coming back to this autographic tradition. One can say that when you design parametrically, with AI, without AI, doesn't really matter, the result of your design is not one particular building, but a series of buildings which would vary or which would vary a little bit depending on changeable parameters. So the result is not some ideal object, but rather a rule-based process, something very similar to an algorithm, which could, in different materials, in different places, in different contexts, result in different buildings. In this context, he believes that AI, he came up with this thesis before AI became really a thing, around 2008, I think. His first books about the topic started. But he believes that AI is something which speeds up this process significantly. All right, what else do we have here? Backpropagation and neural network. I'll start with neural networks. So when we say AI nowadays, we basically almost always talk about neural networks. The term AI was part of science fiction thinking before neural networks came along. And also neural networks, when they came along, for a long time they were mostly theoretical concept because they were not very useful. The idea behind that is that our machines could be built in a similar way as our neural network inside our body is built. You have inputs, you have outputs, and you have different connections. The connections should kind of represent neurons within our body, and different neurons, if they are reinforced, they become more important. If they are kind of forgotten, they become less important, and so on. So network optimizes itself. I think biologists hate this definition or hate this name because it seems that neurons within our body work in much more sophisticated and quite different way, but the name stayed. This system, this idea of using this neural network analogy for computers comes from 70s, but the big jump was the idea to use parallel computing made possible by the cheapness of video cards, and that comes from 2000s, 2010s, where it all started. And big idea behind how to make it successful was the idea of backpropagation. Backpropagation basically is a way how to, if I come back to these comics, how to make sure that the output is good. Basically, you have kind of random neural network, you start sending data, most of the outputs are bad. Whenever they are bad, you kind of silence those neurons by which they came, these bad outputs came. Whenever they are good, you reinforce those neurons. So going back along the network and adjusting the weights of certain points is how the network optimizes itself. The simplicity of that process allowed it to run really fastly. You can have millions, now probably billions iterations a second. So for that reason, networks can train itself really fast. Of course, you need massive computer power. While early neural networks were possible to train on your own computer, now things like large language models require huge data centers, which have the consumption of energy similar to a city. So that achieved really massive scale. In 2017, we tried to delve into this topic a little bit deeper in our academic environment. In Imrem, we also invited several specialists. I think the most successful was idea to invite Mateusz Wierzycki, a Polish computer scientist and architect, who together with a couple of others created a plugin OWL, which introduced these very simplified ideas of neural networks and backpropagation to the software Rhino and plugin Grasshopper, which lots of architects use or used, at least back then. And we did very simple tasks because that was very short workshop. The idea was we would come up with a couple of shapes which for some reason we liked, and then we would ask neural network to learn from these shapes and to propose some other shapes which would create some sort of a gradient between them. If you, I mean, everybody could imagine this sort of thing with colors. You can have this gradient where here you have red, here you have blue, here you have green, yellow, etc., and you have everything in between. But colors, if we talk about RGB, they are three-dimensional. You have amount of red, amount of green, amount of blue. Whenever you have a shape like this, even relatively simple shape like this has maybe 20 dimensions. So it's very hard or computationally very difficult to do in a straightforward process to calculate kind of the middle point between 4 20-dimensional vectors. At least I would not be able to do it. However, with neural networks, it's something which is relatively easy to achieve. And basing on this idea, where instead of calculating, you kind of simulate, you basically tell neural network that the result should be something like that, and then it interpolates, and then it knows what to expect. A bunch of programs was created. One of them was created by company Infrared, who has an article in Array Edition. Another one, this is Orbital Stack. There are a couple of others. Most of these programs deal with environmental simulations. Environmental simulations are not a new thing. Maybe some of you used it as well. It's basically simulating the behavior of different things like light, like wind, like amount of shadow. Could be pretty much anything. Traditional way to do it is to calculate it. With light, you know from where the sun comes at what time. You can calculate where the rays come. If you want a little bit more smart simulation, you would also consider the fact that if you have a white facade, the rays would reflect from it. If you have a glass facade, then it would reflect even more. If you have black facade, that they would be heating it, and so on and so on. The traditional way to simulate it, to calculate it, is done through numerical calculation. There is no analytical formula. You just have to calculate one ray after another. For that reason, it's very time-consuming. What companies like Infrared do is they do these traditional calculations for a bunch of examples that will take a lot of time, but they have time. They're developing new software. Then they would feed the result of these calculations to neural network, and then it would train itself. So when you would give the neural network new geometry, new city, new building, whatever, it would not calculate it again. It would just estimate. It would just predict. So it would say, okay, this building looks a little bit like this example I had in Vienna, which I calculated, and there it resulted with this sort of heat dissipation, with this amount of sun, etc., etc. So probably it would be similar here. So it does this sort of prediction. It's less precise. As far as I understand, the kind of deviation from the real calculation could be up to 20%, which is not little. But the advantage is that it's extremely fast. You can get you can upload the 3D model and get the result, the heat map, or the amount of sunlight, or the amount of shadow, etc., in a matter of seconds, sometimes maybe faster than a second. So basically live, which means that you can test lots of different options, pick one or two, and then with these two options which you picked, you can do traditional numeric calculation, which would be very precise, but you don't have to do this numerical calculation for hundreds of options, which would be not possible. The same thing, orbital stack applied to fluid dynamics, basically the behavior of wind, which is even more complicated and time-consuming. The same thing is currently applied by render engines, because when you render something traditionally, it's very similar. You just calculate where the light goes, how it reflects, and so on. Okay, and that brings us to the images. Finally, something which everybody probably expected me to talk about. This development of neural networks led to two things. GANs, generative adversarial networks, and diffusion models. both types of networks were kind of concerned with working with images, with basically two-dimensional grid of pixels. And I think right now, I'm not an expert on diffusion models, but I think right now Midjourney and Stable Diffusion actually start to combine some elements of both, so you don't have pure diffusion and pure against. But in both cases, the idea is this. You have input that data, which are lots of images, huge library of images. You can think of whatever you find on the internet is probably in the library. These images are supplemented with words, prompts, some descriptions. These descriptions are very wide. If you have an image of a house, the description could be a house, but it could be also, if the house is white, the description could be white. If the house is drawn by hand, the description could be hand-drawn. So anything you can think about. And the network is trained to find the relation. Okay, why this bunch of images have common description house and this bunch of images have common description train? I don't know. It tries to find what are typical things for a house. And to make things more complicated, it basically splits these images into small bits and try to find a connection between those bits and the descriptions. That's the learning process. The creation process is different. Again, I'm not stating that this is exactly how it works now, but that's how it used to work when the technology started. Network in general starts with noise, with completely random mix of different pixels, which don't mean anything. It has a prompt, a text description of what you want to achieve, and then it tries to find, okay, in this noise, for example, you want the network to generate a house, and it tries to find among that noise some combination of pixels which within the network's memory somehow relate to a house, and some other combination of pixels which in network's memory is not relating to the house. And it enforces the one which are related to the house, and it kind of tries to negate the one which are not related to the house. So it starts slowly, step by step, step by step. I'm saying slowly, actually, it's a very fast process, but with lots and lots of steps to create a house. Of course, it's much more complicated, and the biggest breakthrough within that technology was when the network started to learn not only on the images it found on the internet or in the library which was put there, but on the images it generated itself. So it started to sort of self-learn. That actually added to a problem, and that's a common problem not only for these image generating tools, but all sorts of AI tools, including large language models, is that as soon as it learns from itself, it reinforces its own bias. So if it starts with some sort of bias, if it so happens that most of the houses in the original library have, let's say, flat roof, it generates more images of the houses with flat roofs, and then it fits itself and learns itself more on the flat roof houses. So whatever the bias is there, and by there I mean basically on the internet around us, network only reinforces that, unless it is intentionally cut off, and there we are with both technical problem. There is only that amount of things you can cut off, but also ethical problem, how much cutting off is censoring it, and so on and so on. Anyway, that's the image generation is probably the most kind of exciting bit of it. So when Midjourney and DALL-E and other things were out, we couldn't avoid to try it out as well, both in the school and in the process. Just here some images of what our students were doing, both in 2D. So this is just generated image. It doesn't make any sense from like point of view of like if you had to draw a plan or a section, but also in 3D, because immediately after you had diffusion models like this, there were immediately tools which would help you to get this into 3D. It was an interesting experience. However, for me myself, completely unsatisfying because it was a little bit like playing without knowing any rules of how to play it. This sort of use of neural networks for ideation is, or coming up with an idea, is something quite questionable. We tried it also in the office. We were doing a project of a 3D printed bus stop, and at some point there was a big change in technology and in partners, and we are a bit out of ideas. So to give us ourselves a push, we said, okay, let's ask diffusion models to generate some ideas for us. I don't know if you would say this one is a photo, so I don't know if how much it influenced our design. I personally think not too much, but maybe there is something in it. I don't want my personal skepticism to the use of diffusion models limit you. I think I'm just maybe not very good at it, but I think maybe even today Jaké will show you much more successful approaches with that. Yeah, I would end with this point. So thank you.
Many thanks for the invitation of our lecture presentation. This is the Introduce to AI. Shota is going back to Prague. If you have some question, you can put here. But after that, we will start at maybe 2 p.m. with the online presentation from Bratislava. That Jan Pernetsky have some problem in family and will lecture only by internet. Some question for Shota, easy, or your generation and I.
The same. Thank you.
Some question or not?
What about application in your?
Sorry?
What about application in your studio? Do you plan to dig maybe more deeper into it?
I want to, but the deepest I was digging was when we had, I mean, you know all about it, when we had this change of 3D print manufacturer with the bus stop.
Yeah.
So that was, we had some time, we had completely changed design, and I thought at the time, okay, that's time to try. And I didn't want to use Midjourney, and I didn't want to use the DALL-E for the reasons I explained, because they reinforce sort of, at least back then they were reinforcing sort of mainstream internet images. So I tried to create my own library, Stable Diffusion, which was open source version, allowed, probably now it's much easier, but at the time it took me quite some time to create my own library of images of different tests. Mostly I tried to make library out of tests with like gypsum and stuff like that, and then to generate images out of those tests. So I picked 3 images just for this slide. There was of course more of it. I think at some point it influenced the design a little bit, but I'm still very far from having strong idea of how this has to be done, how to do it for it to be successful. So I'm a bit on the wall, on the hinge.
Mm-hmm. Let's see.
I have some question about situation in Imrem. What is the between pedagogue and students? How to use the AI for the 10%, 20%, 30% for the education and other?
I think
if exists some
yeah.
standpoint about it.
I think there is some rule, but it only concerns like texts. So you shouldn't write your diploma thesis through ChatGPT, or whenever there is at least a little bit written, you should always mention that this bit is written. But Imrem is obviously mainly art school, so I think they're a bit lost also how much to kind of limit students. For now, I think the general idea is you should always tell if you use it. If you use Midjourney to generate something, if you use something else to generate something, you should always mention it. and then depending on the context, the jury or the teacher would say, okay, fair enough, or they would say, are you crazy, that's unacceptable. I don't know, with our students, in our studio we don't mind, but we are also maybe becoming immediately more critical. The same image, if they draw it themselves, we would be maybe more accepting than when this image was generated by computer. But if they have good arguments and if the image is really good, why not? We're still not at least the expertise of our students and of us is still not at a point where you can directly take it and use it. You can take some idea, but you still need to do a lot of drawing and modeling to be able to use it.
Okay, it is AI and education is from the school. This is the question about how to compare the situation with AI. This is a help, again.
I don't know. I think it's something which cannot be avoided. People would use it anyway, so it's better to take some positive approach and just to make sure it makes sense. I mean, with ChatGPT, probably most of you who tried it already noticed it likes also to make stuff up completely absurd things, so you have to be careful, but also it gets better.
We will see to discuss maybe in the next 2, 3, 4, 5 years.
Yeah.
Okay.
3, 4, 5 weeks.
Weeks? You mean? Okay.
Okay. Thank you very much. Unfortunately,
okay, we change the program, and usually has maybe 20 minutes, and after Jan Pernetsky and Dan, you can continue about it. We have the time to 4 p.m. no problem.
So I'm very happy to be here with you. I'm very happy to have such a great speaker here. Should I explain all the basics? So I will dive more into the kind of practical usage. Because, in the context, we were actually mesmerized of the digital potential, and it's changing because, when we started studying architecture, I don't know, 20 years ago, we had the first computers, right? And they allow us to think differently, or it was kind of vague that we were very happy to have these computers. It's very interesting that nowadays the students are not that happy, and they are going a little bit back into the drawings and 2D sketches and illustrations, and it's actually understandable. But let's say, it's my personal attitude to computers, because I don't like my drawings. Now I'm much better with that, but when I studied architecture, I was really bad with drawings. And I realized actually when I draw something, I repeat myself. And I was really trying to go further, to try something new, to really develop new ideas. And then I realized that with the computer, it's much easier and much more kind of exciting experience to actually finding something new. Because maybe it's also a personal thing that if you try to understand the architecture or work around you, you have two options, right? You kind of observe the reality and then you mimic or redraw or something. Or you can try to understand why is that, what is the essential, what are the rules. And I'm that kind of person that I'm really trying to understand the rules behind that. And then if you look at the nature, you see that it brings a lot of richness, lots of variety, lots of diversity. And I hope that architecture could be like this. It could be really based on the rules which are based on nature. And when we actually study architecture, we study from the, let's say, examples of modernity, examples of old architecture, which is okay, but it's based on some let's say, rules which are maybe not valid today. And we should be careful about that. If these rules helps us to develop really kind of good result, or if it's obsolete. And sometimes I think it's obsolete. And especially in the cities, when we actually repeat the model which is based on something very different. It's based on different kind of market, different kind of transportation system, different kind of social system. And we should move from this. And it's very difficult to do it by drawing because, for example, city is too complex. It's very complex to draw. So then the architects go to the shortcut to make, kind of simplification. And it's also important to think about egg or chicken. And it's very tricky in AI because, as you know, and Shota mentioned that, and it's work of Mario Carpo, saying, okay, if we use for the data set what is existing, we just regenerate what is existing. It's not innovation. It's just, tiredness, repeating something what was already there. So then, and that's tricky with all these generators by AutoCAD and so on. I think they stopped because they developed this picture. It's beginning of doing they software called Forma, and it was generating tool. But when they presented, they say no, all decisions is yours. There are AI, but just for analysis and so on. And now, I guess I tried this today, and I think that the Forma is not generating AI just because it's not capable to do it, but just for not scary architect, which is very interesting that we are forcing not using the full capacity of AI, but now we are considering if it's more or not, or we fighting with the ego, which is quite interesting. In another model, and my approach is more based on the rules. So instead of using kind of existing data set, you're trying to develop your own data set, which is actually good because then you understand what you are doing, basically. And AI can probably help you to define your concept or methodology, but it will again be kind of reusing someone others. So it's much better to use your own thinking or your own concept. And in this, we call it, okay, you have kind of task or desire. You build a vehicle, meaning you have rules, parameter model, AI models. Then you generate the proto-architecture, and then you apply it. And then you recycle this process to achieve what you want. And my personal kind of almost decade problem is called successive palimpsest. So I'm thinking how to make a city kind of growing as a forest, and as you know, the forest not happen just in one day. It's going from the grass, from small plants, then bushes, and so on. And in the city, we should also think in this context because always there is some context. And nowadays we are able to analyze everything almost. And in minutes, right? So in program, volume, transportation systems, networks, it's really very easy to, let's say, analyze, but then you should have some idea what you would like to do. And with the students from Brno, we did this testing of successive palimpsests in the very interesting area in Brno. They are, abandoned because the task about the train station in Brno, it's funny because there is already a train station, but it's not using. And there are others, and we thought, okay, if we analyze this network and then connect these train stations into the fabric of the city, we actually can really change the scope of the city and accessibility, and also kind of mental map of what the city is. And we started with a parametric model, so we actually get a quotation idea, and then we generate kind of prototypes to see how it looks like. So this model is quite straightforward, but definitely it has certain problems because you are not able to calculate with all the parameters, right? You have like 5 or something like this. And then we said, okay, this is too kind of strong hammer. Let's think about that differently. And this is from my work, from my diploma thesis in the Vystudoval, and also we push this concept with Jakub Kopec and Michal Mačuda for the kind of urban development, and we call it solar envelope, which is actually based on the Ferris drawings when you have skyscrapers and you are trying to achieve shape which gets as much sunlight as possible, but also on the other hand it's trying to get as much volume as possible. So you have two kind of conditions, they are fighting together, and by hand you are not able to do that, but with the computer you are actually saying, okay, just move this point up, measure the sunlight and measure the volume and try to find solution which is maximum for every cell, let's say. And that's very interesting that actually start to negotiate between us. So it's kind of democratic solution. And because if you shade other building, it's wrong, right? So it's trying to find a kind of balance or harmony. And you are also able to add kind of conditions that where is the, let's say, rays or kind of axis that the volume shouldn't be there. So it's also going in, let's say, repetition to trying to find a new solution. This is already almost a decade years ago. It was competition for the airport city. It's actually it was interesting because in the first round we were chosen because for the architects it was like, oh, okay, this is interesting digital project. But then we went really crazy that we generate everything, and it was scary for them a little bit. But in this methodology we try to optimize or generate the street structure. Then we develop the solar system, solar envelope, and we measure that, but then we cut it, like the plates. And then we realize it's really wrong decision because, you know, it's kind of straightforward, just, you know, you click, you cut everything, measure everything, but it's again quite a modernistic way how to think about, let's say, distribution of the spaces. And then also the Jan Pernetsky, he's quite hero for me. We collaborate for almost 15 years. And he developed the software called Monocells, which is very interesting because it's based on kind of topological distribution. So let's say I will explain it in this module. You can say, okay, I have private modules, semi-private modules, public modules, meaning you have flats, you have common spaces, then you have, for example, markets or whatever. And then you set the rules. What should be connected to what? So you make actually kind of topological map, and then you apply this map into the solar envelope. So then instead of just, you know, simply cutting the floors, you are able to distribute volumes according to some rules, which is quite complex, but it's very, very connected with what city is. City is complex. And then kind of using or interpretation with the stable diffusion model. So you have sketch from the Rhino, for example. Then you just color code what is what, trees, meadows, water, and then you are able to make a sketches. So again. So this present doesn't exist. It was the beginning, like 2021, when the NVIDIA developed the gun systems and to generate the portraits. This guy doesn't exist. This page actually, when you click in it, it will generate the new, actually very sophisticated representation of portrait, but it's not real. But it's going into this using neural networks. We did workshop with Daniel Beležan. He's also my colleague from the Vystudoval. And it was quite interesting because we generate our own data storage for the project. So you, for example, in my case, I was interested into the blending the Mediterranean cities with the dunes. So one data set was dunes. Another one was the cities, and I start to train the city that will start to behave like the units. And it gives me a lot of quite interesting results. What was very interesting that the process was very painful. Like for generating this short video, you need at least 2,000 pictures for dataset for the dunes, another 2,000 for the cities. So it will take some time, like 2 days, just to. And then we use actually free networks. I will show you later. And each network was like for every day. So this actually cost like 1 week of work. But it was very interesting, and what was great that you have control what you are doing. And the first gun was pix to pix, like Shota mentioned. So you have input image, and in this case you have kind of cadastral image and orthophoto, and then you train them together, because then you actually apply your own design as a cadastral map and you generate the orthophoto map. And another way, because this is about guns, neural networks, but to generate the dataset for the guns, you need to use, let's say, parametric design or straightforward algorithm to, let's say, measure thing, right? So this is also kind of my expertise, let's say, that it's you have kind of task, and you try to understand what task is, right? And okay, you have volumes, you again measure solar radiation, you measure the mass, and also you measure the view, and you measure the distance between buildings. And for all these parameters, you are able to run the algorithm that it's trying to find the best position for that. And yeah, instead of kind of drawing thousands of variations, you apply the algorithm, and during, I don't know, 1 hour, you will get the results. You actually can kind of measure every iteration and then make a dataset from that, or you're trying to find the best solution. And then the combination with the stable diffusion, you are able to make a really sketch in minutes for the clients. And that's also Shota was talking, okay, what we should do with this stable diffusion. It's actually, let's say, tool for sketching or maybe developing the ideas. So it's not necessarily saying that it will be like this, but you are trying to find some properties or some. And nowadays we are working with Jan Pernetsky, and he will explain the Kubu more. But it's a very sophisticated tool how to develop urban structure. And let's say from the noise, it's called design by constraints, and you actually adding the constraints to the, let's say, count of the points and trying to find the best solution. Amazing thing about this, again, it's not kind of final state, but you are able to generate a lot of variations, and then you can decide what is your actually architecture aim, you know. And this will take 2 hours for you. So it also can say, that's the meaning of the AI, you know. It's not kind of intelligent that will help you with everything. It helps you to focus on design. So instead of making, you know, a lot of drawings or a lot of kind of painful work, you are able to focus on architecture qualities. This is another example. What I really like on these methodologies in parametric design or AI design, it's that it will brings you some ideas also. You know, you can observe the design tool is much more wider, and then you are able to, you know, find maybe solution which is not obvious. And then about stable diffusion. So when it came, it was much more easy than to generate 2,000 pictures for the dataset. So we start to explore the, let's say, design pool. And this is all, it's actually still about successive palimpsests. So this middle picture, it's called, the prompt was successive palimpsests. Then you see the kind of modernistic way, and then some kind of variations. But then creating this you can end up when you would like to be, right? So it's not just that you actually type the prompt and you have some result, but you continue with the process. Maybe make some mixtures, adding the prompts, adding the ideas, and then you are able to go somewhere. It's more like curating. Because when you start generating urban design, it's very much based on the common ideas, and then to translate it into the much more, let's say, nature-based, it needs some skills and time, but it's possible. And then, yeah, then for example, when we were in the position when we would like to be, so you are able to control the small part, like the roof or courtyard or details. And these are some examples which I really like. Back then, I was thinking, okay, so we try neural networks, we play with the stable diffusion. What if we apply the same task, what we did with the neural networks, into the stable diffusion? And actually, instead of 1 week, it cost 1 hour to get good results. So that's the point. The AI world, it's evolving every minute. So what was true like a week ago, now you can try it again and it will be improved, which is really great. So then, like the previous video took 1 week, this took a couple of minutes. And yeah, maybe for you it doesn't mean anything, but for me it's a very interesting design tool, how to look at the kind of blending the architecture, city, and nature. And if you are really tired, so you can generate your own Futurama city with your own, let's say, design or idea. And that's amazing because it's not necessary to use AI just a generative tool. It should be also for the communication, right? So then also to get some ideas, generate the video just from the prompt. It's also very easy today to do. But for example, if you have your own design, you are able to easily make a video from it. And then, let's say 3 months, 4 months ago, my son was interested to make some kind of game, and he developed idea about the game characters. And it was kind of really nice experience with him to very easily develop his idea into the picture and then into the 3D model, because nowadays you are able to, from the render or from the photo, make a 3D model and then you print it. So you have idea and in 1 hour you can have physical representation, which is very good working with the birds and this kind of game characters. It doesn't work good with architecture now, so it's good news for you. There is plenty of work still, but there is also, because this is the project we printed 2023. It's a house, but this is the video by AI. So we generate let's say we make a visualization with the Pro Studio M.Sc and then we translate it into the video. And let's say you are able very easily to make a short introduction. And that's also about how to bring this all ideas that we have into the physical world. So instead of just painting the small character game, you are able to paint a full-scale house, which we did in Janocazovo with the eyes. And in this case, we also use a lot of, let's say, parametric design and AI, because we measure all the prints, we collecting the data, and then we are able to analyze what is happening. And we tried this house 2022, and we had a lot of problems with the shrinking cracks, with the preciseness of the print. So we then dive into the process actually during the winter, and then in another year we were successful. We don't have shrinking cracks. Paint is amazing. So, and all these structures are actually calculated with the AI. So we say, okay, try to find the best shape for the inner structure, and then we test it and use it. And then just we finished the cable car station in Mravka, 3D printed building to the restaurant and control room. And that was also a very interesting project, that we should change the building process into the, let's say, for the cable car control room just for 1 week, because they end the winter season, let's say, in end of March, and then in 1st May they start the biking, right? So the window was very short. And this because we paint the more parts during the winter, so we were able to assemble the control room in 1 week, and then we continue with the rest. But the whole building took 6 months, which is quite good, I think, time. So to conclude, don't think that only stable diffusion saves you. No, you should combine a lot of different neural networks. You should make your own parametric design, then generate your data set, then you apply this kind of process. It's also a lot of experimentation. It's not just straightforward process. But what is very interesting, and it's because in this era we have an amazing Farva Chomsky. He's saying, okay, AI, it's not like the people, it's not intelligent, and it's true. No one's saying it should be intelligent like we are, right? It's just a tool, like the hammer, you know, and maybe just more powerful hammer. But we shouldn't. I think we shouldn't try to make AI equal as us, because it's nonsense. You know, it doesn't think, it doesn't make meanings, it doesn't build kind of senses. But it's evolving, right? Because the Chomsky is saying, okay, it's not, you know, good and so on. And then there's a part that his friend asked ChatGPT if it's moral to go to Mars, right? And in his answer, he goes, you know, I'm AI, I can't decide it. But I tried it today, and it's actually much more different answers. It's saying, okay, you have these problems like philosophical, biological, whatever. You should choose it, you should think about it, but maybe go to the Mars, it's your last chance because you destroy Mars, right? So maybe look at yourself and try to think about your environment. So it gets some kind of critical thinking already. So I asked Chat, hey, what changed, you know, for last 2-3 months? And it says, okay, it's quite funny question, but yeah, I got deeper understanding of philosophical problems and more kind of that I am able to be less wrong, which is interesting because, you know, like a couple of months it was not like that. And from my discussion with Jan Pernetsky, he just showed me yesterday that it was not there when we were in the Brno with the ERA, but nowadays there is a platform called .new, where you are able to actually write the code with the AI. So you just type, you know, what do you want to have, and it will actually make an application for you. So, and it's very handy that you can just, you know, say, okay, I would like to generate this. I have 3 parameters. Add that I'm able to download it, and it took me like 15 minutes, maybe less, maybe 20, to get your own program. So now, I mean, it's exciting times. Thank you.
All right, so I don't know whether I should introduce myself, but I guess I will. Nonetheless. So my name is Jan Pernetsky. Most probably you don't know me, but I used to be all around the place. Just a couple of years ago,
when I was evangelizing computational design. Basically, what we are talking about today, the AI in architecture is a subset of a more general term, computational design, when we use computers to generate architecture. I used to teach, create tools for architects, and design myself. But today I'm here on behalf of a brand, Cubu, which I'm one of few founders. And I would like to introduce you to what we are doing at Cubu and how this could be interesting for architects and for the future of the building industry in general. So Cubu is a software. So we are a software company, and we are developing a solution for architects, real estate developers, but also municipalities to improve the design process of residential buildings. Yeah, like this. So we have identified a lot of problems that the current stakeholders, when they want to build a residential building, they need to overcome. The main problem is that the current design process is very iterative in a serial way. So whenever somebody assigns a project, the project is delivered in stages. Each stage is evaluated by the developer or municipality or the investor. When anything needs to be adjusted, it's being adjusted iteratively, so repetitively the same task is done, performed by the architects and engineers over and over again. And each time the evaluation, whether the solution complies with the anticipations, the evaluation is done afterwards. What we are trying to tackle is to shorten the period when, how long does it take to actually design a building? And at the same time, we want to make the building design process informed, so that all the decisions that the architect or developer is making are based on information and evidence and proof. So instead of having the serial repetitive process, what we have is a generative process. So the computer generates something in multiple versions. It's evaluated in real time. So while the design process is underway, and all the versions are scored or evaluated and delivered to the user with the score, with detailed reports, with actionable data that all the decision makers can base their decisions on. So they know very early in the project process whether the project is compliant or not. These are some main pillars, but I think I will go through the details later on. I will just tell you what do we do differently. So there is the usual generative process, the parametric design that you might know from Grasshopper, Dynamo, or whatever software, and also single source solutions like TestFit or HiPar or Forma and so on. We are slightly different because we are basing our solution on architectural concepts. So one of them is discrete design. So what we do is that instead of putting together geometry or putting together architectural elements or construction elements, we are putting together pieces of space that are discrete. It means that they have a very distinct beginning, then there is something within the envelope and the end. Whatever fits into this piece of space, chunk of space, is our data, and we put together the data in a meaningful way. The rest is not that interesting for your purposes, but we can come back to that if you are interested later on. So from now on, I'm going to show you the outputs of our software. This is a presentation. This is not the software itself. I will show you the software later on, but just everything that I'm showing in this presentation is already generated in our software. So what we do first is we generate the urban scenario, which means that the user comes with a building site, with a project that has certain targets. You know how many buildings you want to build, how many families you want to house, how tall the buildings should be, what is the local building code, how far from some environmental obstacles can you build, and so on. And we are creating, we call them urban blobs, or basically rough shapes of buildings that you can distribute on the site. This is all based on a lot of evaluations, a lot of measurements that we make, and we are trying to optimize multiple targets at the same time. So maybe you've encountered, maybe you know something that is called solar envelope, which is something that quite often is being done. Once you are in a dense urban environment and you want to be sure that your new building is never going to cast any shadow on any surrounding building, you can create some sort of a tent. It looks like a tent. It's called a solar envelope. And you are sure whenever you build underneath that solar envelope, you are never going to cast any shadow on the surroundings. This is way too defensive. This basically doesn't allow you to build to the full potential of the site. What we do is we evaluate a lot of other aspects, including the shadowing, but the shadowing can happen partly. So you can cast a shadow on an existing building where there is no window and so on. So we take all these things into account while we also are optimizing the shapes of the buildings. And what we offer is a rough shape of the buildings that you can take and convert into the buildings, or you can delegate it to our software later on. So this is an animation showing what happens after you already have those urban blocks. Then you take some very generic typologies of buildings. So you know that your building is either a linear building or a tower or an urban block or something like that. And our software then finds the correct position and size for that building to be as close as possible to the urban block. So it means that your building is not going to cause any harm to the environment, and also will have the same targets as you wanted to have at the very beginning. This is also evaluated in the real time. Again, we generate a lot of versions, we score the versions, we deliver the best version or several best versions to the user so that they can choose from those and select the one that proceeds to the next stage. And the next stage is probably the most interesting one from the ones that I'm showing. And that's when you already have a building, a rough mass, basically an envelope of a building, you need to distribute your apartments into that building so that people can live there. And this is called flat mix or in different ways. What you usually have is an envelope that looks like something here. That's a rough floor plan of a building with the common environments, common spaces already dedicated. So the blue part is a vertical core or a horizontal hallway within a building, and the green parts are those places where your apartments can possibly be. What we do is we distribute apartments within that floor in a meaningful way so that it complies with the expected flat mix, which means that you want to have, let's say, 50% of two-room apartments, then 30% of one-room apartments and 20% of four-room apartments, or any other flat mix. But at the same time, we make sure that the daylighting compliance is there, the areas that the inhabitants can buy or use is within the expected ranges and so on. This is, and this also works for more than one building at the same time. So we can distribute the apartments within the whole development area, or across multiple floors within one building, or when you have multiple building sections within one urban block, we can distribute the apartments accordingly, so that it actually makes sense, that all the apartments are correctly placed, that they get enough sunlight, that they are well insulated, and so on. So that's the whole generative process. We call that a generative pipeline. So the pipeline is basically as it sounds. You put something in at the beginning, then something happens within that machine that generates the individual steps, and at the end you get the final result, which is a residential building or the whole housing estate on a site or multiple sites as well. So I will go through the inputs that you have to provide. So of course you need to provide the environment, which is either a 3D scan or some cadastral map or a downloaded 3D map, or whatever you already have as an assignment. You can input into the software and annotate, this is a residential building in the vicinity, this is a tree, this is a terrain, and so on. That's one thing. Another thing, that this is a new concept as well that we have. We call it an informed space. This might be also kind of interesting. The informed space are basically spatial maps where we draw certain phenomena. So it's not really where something is or a physical object, but where and how much of certain phenomenon can be found in the space. So I will give you an example. This is many informed space in one picture. So each color is a different informed space. They exist in parallel. So the idea is that wherever you put your finger in space, in 3D space, you can ask how much of certain phenomenon is there. In this picture, the green areas are those where you as an architect would like to have some inner courtyards or a garden or something that is not a built environment, but a natural environment. And also the size of those little pieces here, it tells you how much of that you want there. So it's a map of a probability that something is going to be there. The orange thing is how much the area is influenced by a noisy street. So you see that there is a street around. So the closer, the deeper you go into the site, the less there is the negative influence of the noisy street. Also, the gray or black areas are those where we do want to have certain buildings. Like we want to make sure that whenever we are generating something, it's always going to contain a building here and here. So it's a probability of certain things that you want to have on your site. This is both hard and soft requirements. So you can say, I strictly do not want to build here, which is this cross. On this side, that's an electricity line going here. So of course you cannot build there. So it's a hard constraint. You cannot build there. But also you cannot build where the park is expected. But it's a much softer constraint. You can build there, but the solution with a building on the park is worse than another solution where there is no building on that area. And this is an actual project that we conducted in Japan, in Osaka. This is a tower, residential high-rise building, very close to a riverbank. And these are informed spaces. Basically, all of these on the right are saying how close is some busy road. And this is the main road, and these are like side roads. So this one is negative because it causes a lot of noise, and you cannot really access the building from the busiest street. But this is actually a positive street location because you can walk on that street and enter the building. So this is bad, this is good. The same comes for the availability to build. So the blue areas are those where you can build. The red ones are where you cannot build because it's too close to something. So eventually what this is good for is that all our algorithms are informed by the informed spaces. So there is certain preference of a solution that you can influence with the informed space. So on the right side, you see the informed spaces. The blue areas are those that expect certain types of apartments. And the purple areas are those that expect different sorts of apartments. And you see that the flat mixing here is behaving accordingly. So when we say that we want to have something on the corners and nothing else, then the distribution is uniform. But when we say that there should be something on the top of the building, you will see that the flat mix will change accordingly. So you can influence the solution this way. To make this work, you need to have certain data ready-made. And this is the architectural input that is totally uninfluenced by the technology. So in our case, you come with a certain type of apartments and buildings that you resolve perfectly as an architect. I'm kind of, this is kind of not entirely true because you can generate those as well. But just to give you an example, you create a set of apartments that you perfectly fine-tune manually, and you are sure that all these apartments, they work perfectly. And then you can distribute the apartments within the building properly. And to make sure this works, you need to go into a lot of detail. So you design the apartments spatially, architecturally, but also technologically. You also define where certain evaluations need to be made. So for example, where you want to ensure that it's going to be a quiet room, where you want to ensure enough daylight, and so on. And then when we distribute the apartments, we are also making sure that everything works and everything is compliant with the building code and your soft expectations. To make sure that this works, we've got evaluations. That's another set of algorithms that basically give you some numerical values or scoring for certain solutions. We provide a lot of solutions, thousands of solutions for each design stage, and we automatically sort them from the best one to the worst, and you can fine tune what best actually means. Just to give you an example, what the evaluations can be, this is a real life case study that we conducted already almost a year ago. This is an optimization of daylighting. So you see that how much daylight does the estate actually gain, which is this is a project in Ljubljana in Slovenia, and there is a special daylighting requirement. So we've got that Slovenian requirement implemented, and we see which parts of the buildings are compliant and which are not, and we can show where the optimization can happen. So that's one of the daily evaluations. Another evaluation is what they call distancing over there. There's a very difficult system of how can you say that you can build this close the buildings to each other, but also you cannot go too far because you want to keep the city compact. So this is what we do. We are optimizing the distancing from one building to another to make sure that you can actually build that within the constraints. And this is another evaluation that tells us what is the flat distribution, so that we make sure that certain types of apartments are distributed properly and that they get enough sunlight as they are expected to. And then there is another thing that we do is we can take an existing solution and on top of that propose where there is still potential to increase something and where you need to take out certain things to actually make the project work and make it a good place for living. Like that, I think I'm already out of time, but I will just tell you about what we are doing and who we are. As a company, we started 2 years ago exactly. And while we are developing the software, we need to somehow prove that what we are claiming works and is needed. So while we are developing the software, which we call a studio, a Cubus Studio, this is the readiness of Cubus Studio as a product. We are also providing a service to the customers, which are mostly real estate developers, but also architects. So we are collaborating with them on certain projects, and we will decrease and do that less and less and less when the software is getting better and better. And so this is just a plan of what we are doing. These are people in our company. I think this is not accurate anymore. We are more people at the moment. And I've got a little call to action for you. We are constantly looking for people who would like to be involved in the development of what we are doing. And there is a couple of things that you can do. If you're interested, you can become a beta user, a user that starts using our software as it is right now. Or you already have your own project and you want to collaborate with us on that project. It means you will get the software, but also you will get our support so that you can actually deliver the project according to your requirements. Or in case you are interested to join us in the development as a person, we are always open to discuss that. Just to finish this, I will show you how does it actually look. So this is the Cubus Studio, which I just executed right now. This is the version from today, and this is changing from hour to hour. We are improving the solution. So how does it look? Basically, everything that I was showing so far is available as a plugin for Rhino Grasshopper, so you can test it there. But for the best performance and experience, it's much better to use the Cubus Studio, which is this software under development. And what you can do is you can either start a new project and import all your data, or we've got some example template scenes, like for example this one. So you see that there is a site that looks like this. On that site, we want to generate something. The first urban blobs, they are called urban grid in this version. So you can start generating. It's super fast. That's one of very important aspects of what we are doing. Everything is super fast, including the daylighting analysis, which usually, if you know, like Ladybug, for example, or other commercial solutions, we are several thousand times faster. So you see that we computed the daylighting like this on low settings. So I can set it to really high settings. And this is a very complex daylighting that is performed on this urban solution. And at the same time, you can select all the targets that you have. So here you can define what do you want to achieve with your project, like for example, how much of the site you want to cover with buildings, what is the GBA, which is the square meters, what is this FAR, which means how tall and wide the building is, how many buildings do you want to have on site, and so on. So for example, I can require to have 3 buildings on the site, and it will try to find a solution with 3 buildings. If it's possible, it might not be possible on this site. So at least there are 2. There was just 1 before. And on the right side, you've got the reports, and you see what are the actual numbers and whether they meet the target expectations. In most cases, in this case, it didn't meet the expectations. You can change the settings here, set more priority to certain other aspects, and probably you will fit there. And one last thing, this time for real, this is mainly a tool for those who want to build. So municipality, developers, the end users, the people who will move to the apartments, they somehow can insert their expectations into the software. But at the same time, we do understand that this is going to be used by the architects. And everything that I'm showing you is the scenario where you leave everything to the computer to decide. But we know that this is not the case. You as architects, you want to have certain influence on what you are designing. So all of these phases, the urban phase, the building distribution, the apartment distribution, and the final touch can be performed manually. So you don't need to use the generators. I don't have to hit this button, but you will have your tool where you can sculpt, modify, design your building, and then maybe adjust it a little, or certain things are not interesting for you as an architect to resolve. Like, for example, you don't want to distribute the apartments, but you care about the overall shape of the building, which you can do manually, and then put the apartments within that building, and so on. So all of these stages can be either performed manually or automatically. And this is very similar to all the Copilot or AI assistants that you have right now, because they can touch your software. No matter whether you're writing or creating some images, you can do things manually or ask for help your AI companion. And this is exactly what we are doing as well. You can do everything manually, no computer involved. You will get your data. You will understand whether your solution, manual solution, is compliant with what was expected. And if you want to use the companion, you can just hit the button and certain stage will generate for you automatically. That's it. Thank you. And I'm very open and curious for feedback and discussion.
Many thanks for your lecture and presentation. Izzy, do you have some question?
No.
No? In the auditorium, some question? No? Okay, thank you very much to Bratislava.
Okay.
And I hope we will see personally maybe next time here in the Liberci.
Very gladly. It wasn't possible this time, and I apologize. I thank you for your attention. If you would like to discuss things beyond the scope of this conference, please get in touch. I'm always open to a debate, and hope this was informative and interesting for you.
Okay, thank you very much.
Thank you. Bye-bye.
The last presentation is Rendero. It is more practice. It is continue with the presentation of the Cube Jan Pernecký. Dan, you can.
Yes, so hello everybody, we are going to show you a bit about like the possibility of using AI for rendering stuff like during your working process. So we will start with like a brief presentation about like the development during the history of visualization, and then we will showcase you how to use our application renderer so you can use it for like schoolworks and creating nice renders for less time than you need to spend in standard way of the process of the visualization. So when we were thinking about like the way how to implement visualizations processing with AI, you can see this like statement that deadline is the day that the architect starts to work. It's quite a joke, but it always affects like the visualization, because they are like always like in the end of the process. So the time you can spend on the visualization is always like the less time you can try to do like in the process. So this is why we started to think like how to apply AI in the process of creating something. Like when we are speaking about like the history of like describing something, like in 14th century, Mr. Brunelleschi, he started to work with like the perspective. So after that, the artists start to see the way how to visualize the buildings, and these are like the first drawings in the history that they started to create something, how to visualize like the future and how they see like the potential of the pictures of the architecture. Later, the perspective like developed, so they started to create like those nice pictures of like the sections of the houses. And later in 90s, the visualization using like computing, it started like the days. So these are like the first computer generated visualizations. And nowadays we can do like this kind of visualizations. So you can like see that like the difference between like the photography and the visualization. It's like almost like the photography. But when you want to create such kind of visualization, you know that it's like really like time consuming. So you need to spend like weeks of work when you try to catch like the sun and to create like the atmosphere. So it's like really like time consuming, and it's like hard to learn it. So this is where like AI can like help you, and you can like start to create like some kind of like concepts and nice pictures. But as you can see on this image, like when you are using like AI for example generating a Mid Journey and stuff like that, you can see that like those details, like the like very like details of the picture. You can see that, for example, like the balconies and all the construction parts could be like a bit like destroyed, because like the AI, when it's like creating something, the AI is always like a bit not doing the work like properly. So as you can see, like almost everybody knows this picture. It's generated by AI, and it was like in the first days of AI. I can remember like when I saw first time this picture, I was like, okay, like Pope is like really really like cool guy. But then like everyone like understand it's like generated by AI. But you can see that like when you give like the good prompt to the AI, like the result can be like really outstanding, and it can like really nice do the picture that you want. But coming back like to AI, when you put like bad prompt, the AI generates like stuff that's like not real. So it's like really really important to use the AI in the way we would like to have like the output in the right way. So this is why we started to think how to implement in the process like something that we could use for like our work. This is like renderer generator. We will tell you more like in later, but you can create like such nice visualization like this in the generator. And this is something that like every architects need to create in the work. So we are working with like standard models. So when you are using Revit or ArchiCAD or like 3D Max or SketchUp, then you get like this like 3D model of the house. Then you just like set up like the camera, and you have like the screenshot of the input that you then upload into the renderer. So this is something that everyone needs to create in the work of architect. Then we also work with segmentation maps, what is like really important, because as you know, like you can get from 3D Max or SketchUp this kind of map which is called like ID map. So it represents every color in the picture. It represents like the material that is like used in the picture. So for example, all the windows are blue, all the concrete is yellow, and stuff like that. So that then you can like easily decide like how to control like the output of the visualization, and then you get like this kind of result. And we will show you in the generator that like using renderer you can generate this kind of image in like 5 seconds. So the process of like working in standard way that we used to do it like in history, we spent like weeks of doing this kind of visualizations, but using like the AI generator you can do it like in 5 seconds. And this is like again like the input into renderer. So you just like upload basic image of the model, and then you get like this kind of result. So this is like briefly about the development and how we decided to work on this kind of project. And now we will tell you and show you like how renderer works and how you can use it like in your work. And it's like open source project, so you can like render as much pictures as you would like to do. And we will be really happy if you use it, and if you will give us like some feedback. What do you think about the program, about like the tool? And feel free to use it. So when you want to use renderer, it's like really easy. You just go to our website. So it's here. We will send you like the link. We will send you like the link afterwards, and then you enter the dashboard. And when you create like a project, you just decide if you would like to create like exterior visualization, interior, product, or montage. So I will choose like the exterior, and right now, when the internet will work here.
Is there maybe any Wi-Fi we can use for that?
No, nemá.
Oh, okay.
Jiří, ty máš tam hotspot?
Yeah, so now that's the hotspot.
In case it's not working, we'll show you at least the UI on the screenshots, so you can have any a slight idea of how it works, and it eventually will be enough, though it's gonna be better if you see it interactively. This isn't a problem of the software, it's only on the network connection trouble, so please be patient with us.
Tak to neuděláme.
Přes vaši to nejde?
My jsme na Wi-Fi tady, na mobilu.
No, pětko, tak to můžu zkusit. Zkusím hotspot s 5G s jednou čárkou.
To nedáme.
To máš stejný, ne?
Stejný.
Máš Vodafone? Já.
Já mám taky, počkej, tak já můžeme ukázat akorát tu prezentaci.
Jo, tak tam hodíš tu mojí?
Jo.
Okay. Yeah, so it's plain B. We will show you basically only screenshots of the UI, but it's very easy to manipulate and work with. It's very optimized software. Basically, everything is on cloud, so you don't have to have any computational power whatsoever in your PC or in your Mac. And basically, I'll maybe start from this point again, just mentioning 3 main components. First one is the base image you can see there. It's basically just very quick render of a scene, okay? So it's something which you can do in any 3D software for in few minutes, and basically you model the stuff, right? You have some design. You probably are mostly architectural students, probably, maybe. If yes, then you know how it works. So basically this phase of visualization is quite time consuming. So you can very much save some time even when starting with the 3D modeling. As you can see, it looks very bad. And there is no detail, there is only some modules and some parts of this scene very much defined. And then you export or get any type of ID map, as already have been mentioned, which helps the software to really easily recognize different parts of the raster image. And the outcome may be very pretty, actually, considering how quickly it's actually created. I'm not saying it's the best work. There is much more better pictures we are creating in Rendero, but this one is very educational for you. On this picture, you can basically see the difference between the base image and between the render. And just keep in mind, only rendering which is happening is using AI software, AI algorithms. So there is no additional light calculation, no ray tracing, nothing which requires such a hard and a heavy hardware. So that's something very new in any field. And basically, I'll maybe just mention in this part that if you all know Midjourney, have anyone tried Midjourney AI? Okay, so you know you put in text prompt, which basically defines the image, right? But there is no control over the architecture of the image. There is no control over the composition of your scene or any actual physical, precise length, depth, height of windows, of anything, right? And that's something we need in architecture. We need to be very precise because afterwards we want to build it. And before, Midjourney was the first big company doing any image generative AI. And we used it, but we used it only for references and referral images. So we created some images in Midjourney to be inspired by, but nothing you can actually show to your client and say to them, this is your building, we'll build it like this. So on this picture, I'm defining and showing you how precisely Rendera actually keeps the detail. That's mind-blowing for me and very much a big game changer. You can see the links between the, for instance, the concrete roofing beneath, above the car. It actually goes like pixel by pixel precisely at the same spot you export from the 3D, which gives you full control over the outcome. And that's something very, very handy and very unique to Rendera actually. So that's why I'd recommend it mostly. There you can see actually the UI. It's in any browser, so you can use Chrome or Safari or whatever you are using, and you will see this basically. There is first tab, which allows you to input the basic base image. That's something you will have basically from your 3D software mostly. And if you upload it, it actually has a slider which shows you actual value of this input value. So higher value makes it more similar to the base image. Lower value will give it more freedom, and it may result in very different image actually. Then there is a tab for a text prompt that's similar to Midjourney. You basically describe atmosphere, material composition, the overall feeling of your wanted outcome in some short few sentence length text. It's not necessary to use it, but it influences the picture. For instance, if you mention there is wooden walls all around the buildings, it will generate wooden facades. And it's, in my opinion, not the most important part of all those components. The most important one is, of course, the base image, and secondary, the segmentation. And also there is a possibility to use references. So basically you can think of it as a palette of colors. If you have Photoshop, for instance, you pick a color and it remembers the color. So this reference tab basically picks the colors, picks the lighting setup, picks the, you know, anything what you can actually get from these references and applies it to the images you generate, which can be helpful. Then there is a new function in this version of Rendera, which controls how much you will differentiate from the base image, and it allows you to really precisely limit, I'd say, imagination of the program. Okay, so if the renderer was an artist, this slider will make him more or less tripping. Then there is the most important part. I'll probably have even a slider for that. There you can see the process of importing the reference image. Nothing hard. You just click, you just upload the picture, that's it. And then you import the ID map. This may look a little bit more complicated, but you don't do anything with this. Basically, this is automatically analyzed from the base image of the ID map. As you can see, there is the miniature, and then there is all different colors, which the software recognized in the image. You can see also percentage value of each color, which means there is a lot of blues, there is a lot of greens. This one is like the third most recognized in the picture. And you just select all or select some limited amount of the colors you want to use as a segmentation map, which then imports as these slides on the right side. And you can, or you don't have to, define the specification of the segment. For instance, I'm here just clicking on the red one, on the highlighted one, and you can see it highlighted as well on the image. This white area is basically where this segment is, and I'm defining it as large scale or large format paving. It can be concrete, it can be black concrete, anything you choose. And then the software will generate it in this way. In the same way, there is the roofing system, there is the plaster and all the materials you use. Trees may be problematic because there is usually a lot of materials on the 3D models of trees, so you can maybe see it even on this one. Yeah, there is only 2 colors because I've optimized the 3D model already, but it can be more, I'd say, distracting for the software. Nevertheless, when you define all of these, you can also choose references for all of these. So you can have reference for a concrete structure, you can have references for sky, for anything you actually want to make somehow more specific. And then you basically hit render, and it renders. And the outcome is pretty much, I'd say, finished project, right? If you are not happy with it, you can re-render, you can change some settings, change some values, for instance, value of the importance of the base image or of the references. And that's basically how render works. I want to show you one more slide there. There is, yeah, these are outcomes from Midjourney, for those who haven't seen Midjourney working. And it maybe looks pretty in some way, but it's a little bit, I'd say, not specific, right? If you just compare those two softwares, you don't get any results comparable with Rendero from a software like Midjourney, which I'm not saying is bad, but it's a tool for something different. You don't draw with pen, you draw with a fix or something. So basically, we were lacking some software which will have the control over the images. I'm just making sure to summarize it in the end. And we created the software for very specific, precise, and sophisticated architectural work.
That's it. I'm sorry that we can like showcase the render online, but just like type render.ai and you can try it. Like,
you can try it yourselves. That's probably even
works.
better.
Just it's a matter of internet, so so that's it.
Okay, thank you very much. Okay, the presentation finished, and Philip, we can maybe start the discussion, but I don't know.
Are there any questions?
Some question, because 2.5 hours with the AI was very tired. So do you have some question to this to Rendero about the sound system? Or the
How many users do you have?
2K.
Right now, like almost 2,000.
Like active ones which return.
Cool.
Yeah.
And interesting is a lot of them are from India and USA.
Really? I will try.
Yeah, sure.
Yeah, like we started to develop it as like our internal to look at our studio, because like the visualizations are like a bit time consuming, and after we saw like
I was like observing the softwares a lot of times, but I was not satisfied.
yeah, we were not as well because there was like zero control about like the outputs. So
like render, not render, re-render was
Yeah.
closing
Yeah.
there, but it's still
Yeah, there are some tools which are similar. but they are
not
also at the
precise.
beginning. So
Not precise. It's always make changes and
They don't.
or it prefer the sketch
yeah,
over the.
we can
real
also work
rendering.
with Sketch in Renderer. You can just sketch the shape and it keeps the shape and makes it fill.
But I think like the biggest difference between us and the rest is like they don't use like the segmentation maps.
Yeah,
So
exactly.
you have like zero
Exactly.
control over
Yeah.
the output. So
And with that, you are able to control that.
yeah, this is what we decided to be like the unit.
That's why I actually use this segmentation map just to imagine. Like for the imagine, you can do similar thing, but it's still not that precise. You should make your own dataset. And how big a dataset do you have?
I don't know.
Like
actually.
data set of what?
Like computation
training,
power.
or-
No,
No.
it's not working like that. Like it's using stable diffusion model, so it's like
Yeah,
computer.
but for
It's
the
like machine
stable
learning.
diffusion, you should have the dataset, no?
No,
Like
we
hardware.
are using like done
Okay.
stable diffusion. We are using
Okay.
like already trained models.
Pre-trained.
Yeah, it's already trained. We didn't train the model because like it's super cost
Yeah,
expensive.
time
So
consuming,
we are using like the done model.
Okay. Interesting.
About this question about AI versus architecture or architecture versus AI is the question about this is the versus. If the in future, maybe in this time, the AI helps architects or take the work of architects is the question.
Yeah, that's
Maybe
always the
this-
question if AI will replace us, like architects, like a profession, or not. So how do you see this question?
It's easy because it's still tool, you know. There should be some kind of rider or operator. And then you have different type of softwares. I just, trying to Kubu, the Jan Pernetsky software. At the beginning, I was super skeptical. I just boxes, what is this for? But that's exactly, because this tool making something, so I can explore the potential of that. It doesn't mean it will provide the architecture, right? It may be open the design tool. And then, so it will be like that, there will be architects who just use some embedded tools and they actually don't know that they will use it, Then will be architects like they are more clever, so they maybe build their own kind of solutions and combine different tools. And they are architects like Jan Pernetsky or Daniel Dolojan who actually wrote the code, right? And it will be like that, And I mean, the architects, they should be kind of saying, okay, we don't want to work in this field anymore, but it will never happen.
And maybe
Now, what do you
next.
mean?
Like we see it like as just like a tool for help, so we can like save the time. Like for example, we are saving using Render. We know that we save like almost 80% of time that you need to spend on visualizations. So we can provide clients much more visualization in much lesser time with like
save
zero
money.
feedback loop and save a lot of money for them. Like
One picture costs 8,000 crown. So
At
I
least.
don't know the
At least.
subscription. How.
yeah, it's like it's gonna be like subscription based model,
Uh-huh.
and the lower subscription will start at like $40, so like around
40.
like 1,000.
Yeah. So
like that.
then with 1,000 I'm able to make
You will be able to render like 500 images with it.
500. So
But
I-
like when you like try to use it, you need to, for example, click like 100 times
Okay,
before you get like the result that you want to use. But
100 times.
it's like real time saving.
But we save some money. Probably.
I think it's very same like with the AutoCAD because in past architectures, all drawings were usually drawn by a pencil and then by ruler by hand, and it took a lot of time. There were those huge tables and huge studios, and nobody today is thinking about AutoCAD as about something bad. Actually,
I do.
Okay, do you draw your drawings by hand only?
Mostly.
Really?
I don't do
Like-
drawings actually.
Okay. What do you do?
3 models.
3D models. So you use
Yeah.
3D software.
Yeah.
Then that's similar. That's like 3D
But
software
I
is.
don't draw them. I'm generating. 3D
That's
models,
okay.
so
That's okay. But you use software. You don't use pencil.
I
That's
use
what I
pencil.
thought. It's similar like riding horse and driving
No,
car.
it's different.
Yeah,
discussion.
it evolves
But
and
if it will
it's
go in
natural.
this direction, so
Which
it
is-
will make a slaves, from the architects.
I mean, AutoCAD is a terrible solution.
A little bit, yeah.
Yeah, it's,
It is.
but still it's like evolution. So
Because they use it in the same manner like the drawing, right?
Yeah,
And instead of seeing the whole plan as a whole, they are zooming, out in
yeah,
the crazy.
that's true. That's true. But the
Yeah.
point was, it's natural and it will happen, and it's happening. So it's better
but
to know how to use it
It
and
could be
adapt.
bad thing for AI because it has much more potential, like in this generative way.
But we can say that we use the AI for the practice and this maybe systems. We have more time for the thinking about the architecture.
But it's
About-
tricky because
It's very
then
easy.
you save time
Yeah.
and then you don't think. So the solution will be still the same.
Or you don't have to use solve very complicated and boring emails. You can just paste them in ChatGPT, let them generate answers, and you don't lose time this way.
And then it's getting boring, right?
Yeah, maybe.
Kind of generative.
We need a minimal
answers.
income.
Sure, but the thing is that AI has potential to bring a new thing or new concepts, or you can develop new ideas, or you can make something faster, which will be the same, right? And it's exactly based on datasets, right? So, like the Mario Carpo here explaining, if architects using these kind of datasets, there will be nothing new.
Can I take
yeah,
this?
yeah.
But the other is the question, two article in this issue, and or the addition is about the sustainability, about the energize, about the other
I mean,
aspect after the second aspect is using the AI.
Yeah, I think like for example, like when we were running like a studio, we need to buy like 4 super powerful computers, like every each costs like 100K, and with render we can like reduce it, like we don't need it, so it's
but
also, like,
somewhere in datasets there are big machines.
but you don't have to. But you as architect, you don't have to buy it, so you save the money. And
Yeah, but
also-
someone should provide it, so
Yeah, but
that's true.
then it's not that clear, but I mean,
Actually, it's something what I wanted to mention and shift your attention back to the magazine, because we have there also 2 articles which are quite critical to AI, because this discussion can have also moral aspects, or like from ethical point of view. We have the article, Jiří already mentioned it, from Noam Chomsky, world famous philosopher, 96 years old philosopher, who has the question in his article if the artificial intelligence is really intelligent. So, but it's changing very quickly. So, like Jiří already said, that the experiment which is in this article already doesn't, it's not valid anymore. And the second article is from Mariana Mazzucato, which is a professor from UCL, from University College of London. And her article is about the ecological aspects of AI, and it's also interesting to think about AI in this way, because it has also problems with sustainability, because we need a lot of energy to provide the hardware. And so on and so on. So it's also interesting to think about it from this point of view. And I can again recommend to this magazine.
Yeah, it is a dialogue about
maybe
the future.
questions. I need the last question and then I have to
Okay, you are going to
airport.
Istanbul to present your
3D city.
AI collaboration.
More about 3D printing.
Okay, thank you very much. Okay, thank you very much for coming, and maybe 2.5 hours to spend with this is all, and we will the future, maybe here in the university or in the Czech Republic, about the collaboration with AI in the next 1, 2, 3, 4, 5 years. Okay, and around